All right, so our next problem we're going to look at is example 6 from textbook, section 2.5. It wants us to find what is the limit as x approaches 2 of x squared minus x plus 5, all that over x minus 2. So when I plug 2 in for the top, we get 2 squared is 4. 4 minus 2. 4 minus 2 is 2. And then 2 plus 5 is 7. So I get 7 over, when I plug 2 into the bottom, 2 minus 2 is 0. So this is not one of the indeterminate forms we have. So like factoring this isn't going to work. There's nothing to really cancel. If this was 0 over 0, then yeah, we'd try it. Or if it was infinity over infinity, we'd try it. But in this way, there's nothing really we can do. We know that there's an asymptote there. So what we're going to have to do instead of kind of doing this indeterminate form and canceling stuff is we're going to have to just go through and try to figure out what's going on here. So we know graphically, we know we have a vertical asymptote there. Let's think about what is the limit as x approaches 2 from the left of this expression. So, and then let's think about the limit as x approaches 2 from the right of this expression. So the top gets very, very close to 7. As we put numbers like 1.99999 in there, the top just basically approaching 7. The bottom, however, as we put numbers like 1.999 that are to the left of 2, we get something like 1.99999 minus 2. So the negative 2 is slightly bigger. So we're going to get a very small negative number. So the denominator will be a very small negative number. And if you think about what happens, let's just pull up a calculator here and take a look real quick. What happens if we divide by very small numbers? So if we have 1 and we divide it by something that's very small, oops, that's not very small at all. Let's try that again. So 1 divided by something very small, like let's say 0.0001, and we make it negative. That turns into negative a really big number. So if we had 7 divided by some very, very small number, that's negative. That turns into a very, very, very big negative number. So what we end up happening here, the end result of this, is we get back since we're dividing by a very small negative number, this turns into a very big negative number. So what our limit as we approach from the 2 from the left is doing is we're getting closer and closer to negative infinity. Now, when we approach 2 from the right, the top gets close to 7 because something like 2.0001 squared is going to be very close to 4 minus 2.001, so something close to 4 minus something close to 2 is something close to 2, and something close to 2 plus 5 will be close to 7. The bottom will be like 2.00001. Whoops, I wrote a plus here. It's supposed to be a minus. Let me fix that real quick. Yep. The denominator was minus 2. It can't just change to a plus. So 2.0001 minus 2 will just leave us with the 0.00001 part. So that's very small, and this time it's positive. So this will be a very small positive number. Let me kind of draw a line to keep stuff straight of who's with what part. So when you divide by a very small positive number, that turns into a very big positive number. So as we approach from the right, we are approaching positive infinity. So this one is a little different. Since we didn't actually have an indeterminate form, there was no canceling or multiplying by conjugates or any of that sort of stuff to do. And since we couldn't do any of that stuff, we just had to evaluate this by looking at the left and the right hand limit. If this was 0 over 0, then we'd be trying to factor the top and seeing if it can cancel with the x minus 2 and see where stuff goes from there. So you got to make sure when you're doing these, make sure you're in an indeterminate form, a 0 over 0, a 0 times infinity, an infinity minus infinity type form before you start trying to cancel stuff.